So your next test is on solving systems. We are going to be solving them using graphing, substitution, elimination. We're also going to be solving nonlinear systems. So first section that we are working on is solving the system by graphing. So if you look at example 1, luckily for you, each of these functions are in slope-intercept form. So your first one, you have y is equal to x plus 2. So this gives you a b of 2, which means your y-intercept is 0, 2. Your slope is the coefficient of x, so that's 1, which means you're going to go up 1 and to the right 1. So starting at 0, 2, go up 1 to the right 1. You also can go down 1 into the left 1 to go the opposite direction to get that entire line. Remember, with these, you want to extend that line the entire distance of that coordinate plane. From here, we'll just plot the next line and see where the two cross. So with your next one, you have y is equal to 3x minus 2. Your b is negative 2. That's the ordered pair 0, negative 2. Your slope is 3 or 3 over 1, which means we're going to go up 3 and to the right 1. So starting at that 0, negative 2, up 3 to the right 1, up 3 to the right 1. We can also go down 3 into the left 1. So you'll see that these two lines cross at this ordered pair here, which is 2, 4. For number 2, get rid of this y is equal to in the front. Work with x over 4 plus y over 6 is equal to 1, and x minus y is equal to 3. If we work with the first one, if you wanted to get rid of those fractions, you can, or you can just move over the x to the 4th power. That would give you y over 6 is equal to negative x over 4, or negative 1 over 4, x plus 1. From here, we would just multiply each side by the 6, distribute it in. So y is equal to negative 6 over 4, which is negative 3 over 2x plus 6. So this gives us a y-intercept of 0, 6, and a slope of negative 3 over 2. So we're going to go down 3 to the right 2. So 0, 6 is here, down 3 to the right 2. We can also go up 3 and to the left 2. For our second line, that y minus 3 is equal, or sorry, x minus y is equal to 3. We solve for y. I'm going to move the y over first by adding it so that way it's positive, and that would just give me x is equal to 3 plus y. So I can move then the 3 over by subtracting it to work with y is equal to x minus 3. So that one gives us a y-intercept of 0, negative 3, and a slope of 1. So up 1 to the right 1 from that 0, negative 3. Plot that first point, up 1 to the right 1. Can also go down 1 to the left 1. So we have a line that looks like this. These two lines cross at something, or at a point that is not an actual vertex on that coordinate plane. So you got to look at the x value, which is 3.5, and that y value, which is just 1/2. So the ordered pair at which these two cross at should be 3.5, 1/2. For number 3, we're given y is equal to negative 3x plus 4, and y plus 3x is equal to negative 4. For this first one, you have an ordered pair of 0, 4, and a slope of negative 3, or negative 3 over 1. So we're going to go down 3 to the right 1. 0, 4 is here. We go down 3 into the right 1. We can also go up 3 into the left 1 if we need to. So this line is going to extend throughout our entire coordinate plane, and then we're going to move on to the other. If we look at that y plus 3x is equal to negative 4, subtract your 3x over, and that gives you y is equal to negative 3x minus 4. So this one gives you the ordered pair to start at 0, negative 4, and then the slope of negative 3, or negative 3 over 1. So down 3 to the right 1. 0, negative 4 is here, down 3 to the right 1, down 3 to the right 1, or up 3 to the left 1. It's going to give us the line that looks like this. And because these two have the same slope but different y-intercepts, these two lines will never intersect, which means there's no solution. The next part that we're going to look at works with solving these systems using substitution. So if we look at number 4, we have y is equal to negative x minus 6 and y is equal to x minus 4. Since your y is equal to y, we're just going to set these two expressions equal to one another and solve for x. So that means we're going to have negative x minus 6 is equal to x minus 4. If we move the x over by adding it to both sides to make sure they're positive, that gives us negative 6 is equal to 2x minus 4. Then we can add the 4 over. Negative 6 plus 4 is negative 2 is equal to 2x. We can divide each side by the 2. And you have that x is equal to negative 1. You still need to solve for y. So it's totally up to you which equation you plug that negative 1 in for x. It's got to be one of the two original. So if we use the bottom one, we would have y is equal to negative 1 minus 4, which gives us y is equal to negative 5. So the ordered pair that's our solution is negative 1, negative 5. If we look at our next example, we have y is equal to 3x minus 2 and x minus y is equal to 4. For this one, since we have a y is equal to, we're going to take the 3x minus 2, plug it in for y. So this is going to give us x minus, parentheses, 3x minus 2, close parentheses, is equal to 4. Distribute the negative in order to start. That's x minus 3x plus 2 is equal to 4. Your x minus 3x is negative 2x plus 2 is equal to 4. We move your 2 over by subtracting it from both sides. That's negative 2x is equal to 2. So divide each side by the negative 2. And you get that x is negative 1. Now it's up to you again which equation you use to plug this negative 1 into. My top equation is already solved for y, so I'm going to use that one. So that gives us y is equal to 3 times negative 1 minus 2. Your 3 times negative 1 is negative 3 minus 2 gives you a y of negative 5. So the ordered pair that's your solution for this one is negative 1, negative 5. For number 6, you have y is equal to 2x minus 10 and y is equal to 4x minus 8. We're going to set these two equal to one another. So we have 4x minus 8 is equal to 2x minus 10. I'm going to move the 2 over, or the 2x over first by subtracting it from both sides. This gives us 2x minus 8 is equal to negative 10. Then we're going to add the 8 over. So that's 2x is equal to negative 2. Divide each side by the 2. And you get that x is negative 1. Up to you which one you choose to plug into. I'm going to use the bottom one. So that's going to be y is equal to 4 times negative 1 minus 8. The 4 times negative 1 is negative 4 minus 8 is negative 12. So that gives you negative 1, negative 12. For number 7, you have 2y is equal to 2x plus 12, and y is equal to negative 2x minus 3. We're going to take what y is equal to, plug it in for y in that top equation. So that gives us 2 times negative 2x minus 3 is equal to 2x plus 12. Distribute your 2 in. That gives us negative 4x minus 6 is equal to 2x plus 12. I'm going to move the 2x over by subtracting it from both sides. That gives us negative 6x minus 6 is equal to 12. Then I'm going to move my 6 over by adding it to both sides. So that's negative 6x is equal to 18. Divide each side by the negative 6. And that gives us that x is negative 3. If we plug that x into the bottom equation, we're going to have y is equal to negative 2 times negative 3 minus 3. That gives us a positive 6 minus 3, which is positive 3. So that's the ordered pair of negative 3, 3. For our next part, we're going to solve these systems using eliminations. So with number 8, it gives you 4x plus 3y is equal to negative 5, and negative 2x plus 2y is equal to 6. You do not have any coefficient of your x or your y that's the same, but opposite signs. So look at the signs. For your x, you have opposite signs. You have a positive and a negative. You can turn that 2 into a 4, or a negative 4, by multiplying it by a 2. So you're going to multiply the entire bottom equation by 2. Your top one is going to stay the 4x plus 3y is equal to negative 5. Your bottom turns into negative 4x plus 4y is equal to 12. Now you have opposites on your x values, so you can just combine like terms. Your 4x minus 4x cancels out. 3y plus 4y is 7y. And 12 minus 5 is 7. Divide each side by the 7 to get y by itself, and you have that y is equal to 1. Now choose one of the original problems or equations and solve for x. I'm going to use the bottom equation, so I'm going to plug this 1 in for y, and negative 2x plus 2 times 1 is equal to 6. Your 2 times 1 is 2, so that's negative 2x plus 2 is equal to 6. We move the 2 over by subtracting it from both sides. We get negative 2x is equal to 4. Then divide each side by the negative 2. So x is negative 2. If your x is negative 2 and your y is 1, the ordered pair that's your solution is negative 2, 1. For number 9, you have 8x plus 3y is equal to 13. And 3x plus 2y is equal to 11. Now, again, you don't have opposite coefficients anywhere here. So look at your least common multiple between both your x value coefficients and your y value coefficients. Your x value, you have 8 and 3. Your least common multiple there is 24. Your y values have a 3 and a 2 as coefficients. So their least common multiple is 6. 6 is less than 24, so I'd rather work with a 6. However, your y values are not opposite signs of one another. So when you multiply the top equation by one of the numbers, or the bottom equation by one of the numbers, in order to turn that into your 6 or your negative 6, you got to make sure that one of them has to be a negative. So if we turn the top into a positive 6, we multiply the entire equation by 2. If we turn the bottom into a negative 6, we're going to multiply the entire equation by negative 3. Like I said, you need opposites in order for those to cancel. So 2 times 8x gives us 16x. 2 times 3y is 6y. And 2 times 13 is 26. On the bottom, the negative 3 times 3x is negative 9x. Negative 3 times 2y is negative 6y, and negative 3 times 11 is negative 33. You are looking for opposite coefficients. Your 6y and negative 6y are opposites, so they're going to cancel. From here, combine like terms. So 16 minus 9 gives us 7. Keep the x attached to it. 26 plus negative 33 gives us a negative 7. Divide each side by your 7 to get x by itself, and x is negative 1. Choose one of the original equations to plug in that negative 1 for and solve. If I use the bottom one, that's going to give us 3 times negative 1 plus 2y is equal to 11. Your 3 times negative 1 is negative 3. We're going to move that 3 over by adding it to both sides. So that's 2y is equal to 14. Divide each side by the 2. And y is 7. So if your x is negative 1 and your y is 7, that's the ordered pair of negative 1, 7. That is your solution. For number 10, you have 5x plus 4y is equal to negative 7, and negative 5x minus 2y is equal to 1. If you look at your x values, they are opposites of one another. So we can just combine like terms here. Your x values cancel. The 4y minus 2y is 2y, and negative 7 plus 1 is negative 6. Divide each side by the 2, and you get that y is negative 3. Choose one of the originals, plug the negative 3 in for y. I'm going to use the bottom with the negative 5x minus 2 times y, which is negative 3, is equal to 1. Negative 2 times negative 3 is positive 6, so that's negative 5x plus 6 is equal to 1. We would subtract the 6 from both sides to get negative 5x is equal to negative 5. Then divide each side by the negative 5 to get that x is positive 1. So if your x is 1 and your y is negative 3, that's just 1, negative 3. Now for number 11, you have negative 2x plus 2y is equal to 6, and 4x plus 2y is equal to negative 5. If you look at your y values, your coefficients are the same, and they have the same sign. So you can just subtract these two equations from one another. But remember, when you subtract, you have to distribute that negative, which changes the sign on everything within the equation. So negative 2x minus 4x is negative 6x. 2y minus 2y cancels out. 6 plus 5 is 11. From here, divide each side by the negative 6. And you get that x is negative 11 over 6. Plug this into one of the original equations. My top has smaller numbers there, so I'm going to use that. So that's going to give us negative 2 times negative 11 over 6 plus 2y is equal to 6. Your negative times negative, again, is positive. Your 2 becomes 1, 6 becomes 3, so that's 11 over 3 plus 2y is equal to 6. Move your 11 over 3 over, subtract it from both sides. So that's 2y is equal to, we said 6 over 1 is the same thing as 18 over 3 minus 11 over 3. So that is 2y is equal to 7 over 3. Divide each side by the 2. So we can rewrite this as y is equal to 7 over 3 divide by 2 times 1 over 2, which then gives us 7 over 6. There we go. So x and y, put them together. That gives us negative 11 over 6, comma, 7 over 6. Your next example, you have negative x over 25 plus 4y over 5 is equal to 4, and 15x plus 9y is equal to negative 45. Do you want to work with your fractions?
No.
Multiply your top equation by your least common denominator to get rid of the fractions. Between the 25 and the 5, least common denominator, 25. So the whole thing gets multiplied by 25. That leaves you with negative x plus 25 divided by 5 is 5 times 4y is 20y is equal to 100. You also have the 15x plus 9y is equal to negative 45. Now with these, you don't have any coefficients that are opposites. Between the negative 1 and the 15, your least common multiple, 15. Between the 20 and the 9, your least common multiple, I think, is 180. So I'd rather work with the 15. So we're going to multiply the top equation by 15 to cancel out those x's. So that's going to give us a negative 15x plus 300y is equal to 1500. Oops. You also have the 15x plus 9y is equal to negative 45. So combine your like terms here. Your 300 plus 9 is 309. Keep the y attached to it. Your 1500 minus 45 gives you 1455. If we divide each side by the 309, you are left with, one second, if this is in simplest form, 485 over 103. The reason why I'm keeping it as a fraction and not turning it into a decimal is because your first equation has a fraction, so I'm going to keep it as a fraction. Pick one of the original equations, plug that in, solve for x. I don't care to work with the fraction over a fraction, so we're going to work with the bottom equation. So that means we're going to use the 15x plus 9 times y, which is 485 over 103, is equal to negative 45. This is going to give you, if you multiply the 9 times the 485, 15x plus 4,365 over 103 is equal to negative 45. The negative 45 is going to have to turn into something over 103. So 45 times 103 gives us 15x plus 4365 over 103 is equal to 4635 over 103. We are going to subtract the 4365 over 103 from each side. This gives us 15x is equal to 270 over 103. This 270 over 103 does not simplify, so you are going to have to just divide each side by the 15, or 15 over 1. We're going to keep change flip, so 270 over 103 times 1 over 15. The 103 times 15 gives us 1545, which can simplify with the 270. So let's do this. If we divide both of those by 5, this becomes a 3. This becomes a 6. No. 15 goes into 270 evenly 18 times. So let's do that. This becomes a 1. This becomes an 18. So x is 18 over 103. So if that is your x and your y is the 485 over 103, your solution is 18 over 103, comma 45 over 103. For 13, we have negative 0.7x plus 0.6y is equal to 0.1, and negative 0.004x plus 0.003y is equal to 0.004. If we move the decimal point one place to the right on everything on the top, that would be multiplying it all by 10. That would give us negative 7x plus 6y is equal to 1. If we multiply everything on the bottom by 3,000, that would give us a negative 4x plus 3y is equal to 4. Do we have a coefficient that's the same or opposite? No. However, your least common multiple between the 4 and the 7 is 28. The one between the 3 and the 6 is 6. So I'd rather just multiply the 3 by something than multiply both the 7 and the 4 by something. So the bottom equation here, we're going to multiply by a negative 2 in order to get rid of those y values. This gives us negative 7x plus 6y is equal to 1, and positive 8x minus 6y is equal to negative 8. Combine your like terms here. Your y's cancel. The negative 7x plus 8x is just 8, or sorry, just x. From here, the 1 minus 8 gives us negative 7, so x is negative 7. Plug this into one of the originals. I would use the ones that don't have the decimal, but it's totally up to you. I'm going to use the top one. So it's going to give us negative 7 times negative 7 plus 6y is equal to 1. Your negative 7 times negative 7 is 49, plus 6y is equal to 1. Subtract your 49 over. So that's 6y is equal to negative 48. Divide each side by the 6, and y is negative 8. So your solution for this one is just negative 7, negative 8. For your next one, you have x plus 3 over 4 plus y minus 1 over 3 is equal to 1, and 2x minus y is equal to 1. What would you like to do with this one? You want to work with those fractions up top? Get rid of them. Least common multiple or least common denominator between the 4 and the 3? 12. Multiply the entire thing by 12. That's going to make the 4 a 1, so you multiply by 3. The 12 times the y minus 1 over 3, the 3 becomes 1. You multiply it by 4 up top. And the 12 times 1 is just 12. So we're really doing 3 times x plus 3 plus 4 times y minus 1 is equal to 12 times 1. Distribute in the 3, distribute in the 4. That gives you 3x plus 9 plus 4y minus 4 is equal to 12. You have like terms between the 9 and the negative 4, which gives you 5. So that's 3x plus 4y plus 5 is equal to 12. Move your 5 over, subtract it from both sides. You have 3x plus 4y is equal to 7. Now you are working with 2x minus y is equal to 1, and 3x plus 4y is equal to 7. What method should we probably use for this one? You can use the elimination. You can also use substitution. It's totally up to you. So it doesn't necessarily tell you what method to use with these last 3 problems on this page, but like I said, it's up to you which one you want to use. I would do the elimination just because it's my preference on the ones that I choose to do, but you could very easily use substitution. Move the y over, then move the 1 over. You would get that y is equal to 2x minus 1. So you'd literally just be plugging in the 2x minus 1 for the y and the 3x plus 4y is equal to 7 and solving. If we did elimination though, the top you would have to multiply by 4. So that's giving you 8x minus 4y is equal to 4, and 3x plus 4y is equal to 7. We can now combine like terms. Your 4y's cancel. 8x plus 3x is 11x. And 4 plus 7 is 11. So 11x is equal to 11. You are going to divide each side by the 11 and get that x is 1. Using the smart decision on which equation to use from the beginning, I would go with the bottom one. You're not working with fractions, much easier. So 2 times x, which is 1, minus y is equal to 1. 2 times 1 is 2, minus y is equal to 1. Move your 2 over, subtract from each side. You get negative y is equal to negative 1. Then divide each side by the negative 1. And you get that y is 1. So your solution to this one is just the ordered pair 1, 1. Number 16, it tells you that the class is selling food at the school fair. Pretzels cost $1.50. Bottles of water cost $1. The class sold a total of 107 items and collected $128. You have to come up with your own system of equations here. So you got to figure out your two equations that you're working with. If we're working with pretzels and water, we can use variables like x and y. You can use p and w, doesn't matter. But if we sold a total of 107, that means that x plus y is equal to 107. If each pretzel is $1.50, that means that we would have a 1.5x, and each bottle of water is $1. That would just be 1y or y. Total of that comes out to 128. So you have your two equations based off of the information that's given to you. You can choose the method you use in order to solve the system. If we chose elimination, we can subtract the bottom from the top, which means we'd be working with x plus y is equal to 107 minus 1.5x minus y is equal to negative 128. From here, we can just combine our like terms, so add them. Your y's would cancel. That negative 1.5 plus 1 is negative 0.5x, and 107 minus 128 gives us negative 21. From here, we would just divide each side by the negative 0.5. A negative divided by a negative is a positive, and 21 divided by 0.5 gives us 42. So x is 42. If x is 42 and you still need to solve for y, I'd plug that into the top equation and solve for y. So that's going to give us 42 plus y is equal to 107. Move your 42 over, subtract it from each side. This gives you that y is equal to 65. So that means that we sold 42 pretzels. I don't know why I put the two Z's in there. P-R-E-T-Z-E-L. Okay. And 65 waters. For our next one, number 17, it tells us that the given amount of annual interest is earned from a total of $11,000 invested in two funds paying simple interest. Write and solve a system of equations to find the amount invested at each given rate. Our annual interest is $430. Your rate 1 is at 2%. Your rate 2 is at 5%. You need to turn these percentages into decimals. The 2 would become 0.02. The 5 would become 0.05. So you're going to set up two different equations with this. Your rate 1 can be x, your rate 2 can be y. If you invested a total of $11,000, that would be x plus y is equal to $11,000. If we work with the rate 1 and the rate 2, that would mean that we would have 0.02x plus 0.05y is equal to the annual interest, which is 430. Now, I don't want to work with the decimals, so we're going to multiply the entire bottom equation by 100 to move the decimal points 2 places to the right on all of these numbers. This means that we are going to work with x plus y is equal to 11,000, sorry, as well as 2x plus 5y is equal to 43,000. Now, in order to use elimination here, I would multiply the top equation, let's say by -2. So then we are working with -2x minus 2y is equal to negative 22,000, as well as 2x plus 5y is equal to 43,000. Now we can just combine like terms. Your x's cancel. Your negative 2y plus 5y is 3y. And your 43,000 minus 22,000 gives us 21. We divide each side by the 3 to get y by itself. And y is $7,000. To find your x, I would use the top equation. The x plus y is equal to 11,000. So x plus 7,000 is equal to 11,000. Subtract over the 7,000. Your x is $4,000. So at rate 1, that's $4,000. And at rate 2, that's $7,000. For 18, it tells us that the school that Stephen goes to is selling tickets for a performance. On the first day, ticket sales were 3 senior citizen tickets, 1 child ticket, for a total of $38. On the second day, it was $52 by selling 3 senior tickets and 2 children. If we form equations based off of this information that's given to us, it tells us we're going to do x for seniors and then y for child. So the first one is 3x plus y is equal to 38. The second one gives us 3x plus 2y is equal to 52. Choose the method that you'd like to use. If you want to eliminate, you'd have to multiply the top equation by -2, so that way your y's would cancel out. If you don't want to eliminate and you want to use substitution, since we haven't used substitution yet, you can do that also. You would take the 3x plus y is equal to 38. Subtract your 3x over and get that y is equal to -3x plus 38. If you then plug this into the bottom equation, since we haven't worked with the bottom equation yet, you're going to have 3x plus 2 times -3x plus 38 is equal to 52. Distribute your 2 in. That gives you 3x minus 6x plus 38 times 2 is 76. Combine your like terms here with your 3x and your -6x. That gives you -3x plus 76 is equal to 52. From here, subtract the 76 over. That's going to leave you with -3x is equal to 52 minus 76 is -24. So divide each side by the -3 to get what x is equal to. And you have that x is equal to 8. To find what y is, take the 8, plug it in to the y is equal to -3x plus 38. That's going to give you y is equal to negative 3 times 8 plus 38, which is negative 24 plus 38. The negative 24 plus 38 gives us 14. So y is 14. You were finding the amount of a senior ticket and an amount of the child tickets. So this tells you that the senior citizen tickets are 14, no, sorry, 8, and your child tickets are 14. For number 19, sorry. It tells you that a minor league baseball team had a total attendance one evening of 1,270. The tickets for adults and children sold for $15 and $12 respectively. The ticket revenue that night was $17,625. Create a system of linear equations to find the number of adults and children at the game. So from the first part, it tells us that there was a total of 1,270. So something plus something is going to equal to 1,270. Adults were $15, adults are 15, children are 12. That doesn't give us what to put with that 1,270 other than the adults and the children. If we use x for the adults, y for children, that would be x plus y is equal to 1,270. If we use the 15 and the 12 for the total amount for each ticket for an adult and a child, and give that with the total that was brought in, that would be 15x plus 12y is equal to 17,625. Again, it is up to you which method you choose to use. If you would rather use substitution, you can do that. If you eliminate, I would multiply the top by negative 12. This is going to give you negative 12x minus 12y is equal to 1,270 times negative 12 is negative 15,240. From here, we can just combine like terms. I'm going to bring this up here and write your answer out. Your y's cancel. The negative 12x plus 15x is 3x. And the negative 15,240 plus 17,625 gives us 2,385. From here, we're just going to divide each side by the 3. And that gives us that x is 795. If x is 795, we can find y by doing 795 plus y is equal to 1,270. Subtract your 795 from each side. So y is equal to 475. So at the game, there were 795 adults and 475 children. So on your next page, you're working with different exercises here. For the first one that we see, number 2, you're given x minus y is equal to negative 1, and y is equal to x squared plus 1. If we plug in this x squared plus 1 for y in the top equation, it's going to give us, literally, we're just taking this, plug it in to the top. X minus x squared plus 1 is equal to negative 1. If we distribute the negative, That gives us x minus x squared minus 1 is equal to negative 1. We can add the 1 over. This gives us negative x squared plus x is equal to 0. You're going to factor out a negative x from this. So this gives you a negative x times x minus 1 is equal to 0. Set these both equal to 0 and solve them. You're going to get that x is equal to 0 and x is equal to 1. From here, since you have two values for x, you need to plug both of them in and solve for y for both. If we use the bottom, since it's already solved for y for us, we're going to have y is equal to 0 squared plus 1, and y is equal to 1 squared plus 1. Your 0 squared is 0, plus 1 gives you a y of 1. Your 1 squared is 1, plus 1 is 2. That's a y of 2. So you have two ordered pairs here for your solutions, one that is 0, 1, and the other that is 1, 2. So again, the next one I'm going to do is number 10. We have xy is equal to negative 12, and x minus 2y plus 14 is equal to 0. If we use that bottom equation and solve it for x, it turns into x is equal to 2y minus 14. We can just plug this into the top equation to be y times 2y minus 14 is equal to negative 12. This y gets distributed in, so that's 2y squared minus 14y is equal to negative 12. Move your 12 over, add it to both sides. You have 2y squared minus 14y plus 12 is equal to 0. You have to factor this. You have a common factor out of all three of these terms, which is 2. So factor out the 2 to give you 2 times y squared minus 7y plus 6 is equal to 0. Your factors of positive 6 that add up to be negative 7 are negative 1 and negative 6. So this factors fully to be 2 times y minus 1 times y minus 6 is equal to 0. From here, you're going to set every part equal to 0 and solve. So 2 is equal to 0, y minus 1 is equal to 0, and y minus 6 is equal to 0. 2 is not equal to 0, so cross it out, don't work with it. The y minus 1 is equal to 0, move your 1 over, you get that y is equal to positive 1. For y minus 6 is equal to 0, move your 6 over, you get that y is equal to positive 6. So once again, you have two solutions for one variable, not just one. So you have to plug them both in to solve for two separate x values. So if we start with the y is equal to 1, if you use x times y is equal to negative 12, that's x times 1 is equal to negative 12, which gives you x is negative 12. If you did the same with the 6, you have x times 6, which is 6x, is equal to negative 12. Divide each side by the 6, and you get that x is negative 2. So your two solutions here are negative 12, 1, as well as negative 2, 6. The next one that we're going to look at is number 12 before we move on to the addition ones. So for 12, we have x squared plus y is equal to 4, and 2x plus y is equal to 1. If we use substitution for this one, we can solve for one of the y's. I would use the bottom to solve for that y. So that would give me y is equal to negative 2x plus 1. I'm going to take this, plug it into the top, and that gives us x squared minus 2x plus 1 is equal to 4. Because we have the x squared, you want it equal to 0, not 4. So move your 4 over, subtract it from both sides. You get that x squared minus 2x minus 3 is equal to 0. So from here, do the same that you did with the other one. Find your factors of the negative 3. That add up to be negative 2. That would be negative 3, positive 1. So So this factors to be x minus 3 times x plus 1 is equal to 0. If you set them both equal to 0 and solve them, you get that x is positive 3 and x is negative 1. So plug these into one of the original equations and solve. If we use, let's use the bottom one. This is going to give us 2 times 3 plus y is equal to 1, and 2 times negative 1 plus y is equal to 1. Your 2 times 3 is 6. If we move the 6 over, we subtract it from both sides, so you get that y is negative 5. For the 2 times negative 1, that's negative 2 plus y is equal to 1. Move your 2 over, add it to both sides, you get that y is 3. So the two ordered pairs that you're going to have left as your solutions are 3, negative 5. Oops. As well as negative 1, 3. For the next one that we're going to look at, we are going to look at, let's look at 20. So for 20, you have 4x squared minus y squared is equal to 4, as well as 4x squared plus y squared is equal to 4. Our y's are opposites, so we're just going to combine like terms here. The 4x squared plus 4x squared is 8x squared, and 4 plus 4 is 8. Divide each side by the 8, you get that x squared is equal to 1. So take the square root of both sides, and x is plus or minus 1, which means you have x is equal to negative 1, x is equal to positive 1. You got to solve for y. If we use the bottom, we're going to do 4 times negative 1 squared plus y squared is equal to 4. 4 times 1 squared plus y squared is equal to 4. This is just 4 plus y squared is equal to 4, and 4 plus y squared is equal to 4. So it ends up being the same. Move your 4 over, subtract it from both sides. That gives you y squared is equal to 0. Take the square root of both sides, and y is equal to 0. Remember, 0 is neither positive nor negative, which is why you don't put the plus or minus in front of it. So you have two solutions here, one that is negative 1, 0, the other that is positive 1, 0. The last one that I'm going to do with you is number 22. We are given 3x squared minus 2y squared is equal to negative 5, and 2x squared minus y squared is equal to negative 2. That bottom equation, I'm going to multiply it by a negative 2 to get the y's to cancel out. So this is going to give us the same top equation. So 3x squared minus 2y squared is equal to negative 5. But the bottom is going to change into negative 4x squared plus 2y squared is equal to positive 4. From here, we can just combine like terms or add. Your y's are going to cancel. The 3x squared minus 4x squared is negative x squared, or negative 1x squared. And negative 5 plus 4 is negative 1. Divide the negative 1 over to get positive x squared. Take the square root of both sides, and you get that x is negative 1, x is positive 1. Choose one of the originals to solve for y. I'd use the bottom. So this is going to be 2 times negative 1 squared minus y squared is equal to negative 2. And 2 times positive 1 squared minus y squared is equal to negative 2. The 1 squared is 1 times 2 is 2 minus y squared is equal to negative 2. Same thing on the other side. 2 minus y squared is equal to negative 2. So we just have to solve one of these again. Move your 2 over. That's negative y squared is equal to negative 4. Divide each side by negative 1. So y squared is equal to positive 4. Take the square root of both sides, and y is equal to plus or minus 2. So because you have plus or minus 2 for both of these, that means you have a total of more than two ordered pairs that are your solutions. So for the x is equal to -1, it's going to get a -2 and a +2. So that means that we're going to have -1, -2, as well as -1, +2. For the +1, same thing. We're going to have a -2 as well as a +2. So we're going to have 4 solutions for this one, not just those 2 that we first had before.